Courtney Whitcher. I am a PhD candidate at Florida State University, and my research focuses on investigating the evolution of biofluorescence in tree frogs. So there are two ways that species can glow, and those are called bioluminescence and biofluorescence. You're probably most familiar with bioluminescence, so that's what the lightning bugs or fireflies in your backyard utilize to glow, or if you've seen the glowing lure of the anglerfish in Finding Nemo, that's all bioluminescence. And species that use bioluminescence, they all glow in the same exact way. So using the same exact chemical and a little bit of oxygen, they're able to produce their own light. Now, biofluorescent species, which is the type of species that I study, the frogs I study are biofluorescent. Biofluorescent organisms, they take light from the environment and then they re-emit it at a longer wavelength. So instead of producing their own light, they manipulate the light in the environment in order to change their color and glow in different ways. There are these things called photoreceptors in all of our eyes as organisms that help us to see color. And there are different types of photoreceptors. There are what are called cones and rods, and cones help us see in bright light, and rods help us see in dim light. And most animals have only one rod, and that's why when you look at night at something, it kind of looks like it's in black and white. You can't distinguish color as well, especially once we get to really low light levels as humans. However, frogs are really unique in that they are one of the only terrestrial vertebrates, amphibians in general, that have an extra rod photoreceptor type. So instead of having one rod photoreceptor, one structure that helps them to see color in dim light, they have two. And being able to have two means that they can discriminate against color, specifically between blue and green coloration. And so their fluorescence is taking this light from the environment and it's re-emitting it at a wavelength that matches that sensitivity of that green rod. My way to study that is I have different excitation light sources. So I have different lights that I shine on the frog to try to figure out which one they absorb the most and re-emit the most as fluorescence. And then to see the fluorescence, I have different filter glasses that allow me to block out the light that I'm shining on the frog so that I'm only really seeing fluorescence and a change in color. And the lights that I'm using are making the fluorescence bright enough and blocking out all the external lights that I'm able to see that even though I wouldn't be able to in the normal, natural, dark light conditions that frogs can see that in. Sometimes the field stations looked different than each other. We had one field site in Brazil where our field station was actually a mobile field site on a boat where we lived and slept and ate and did all of our research on a boat that was traveling along the Amazon River to be able to access sites that we couldn't access by foot. So we would stop along. We made some really great connections with some indigenous communities of Brazil, and they would help us find the frogs in their area, and they'd welcome us, and we'd eat with them and share stories and cultures, and then also collect our data in the meantime. And so sometimes those field sites looked a little different across all of them, and I got to have some great experience out in a ton of different types of environments all across South America. My preliminary results, which should be coming out soon, seem to suggest that that's the case, that this fluorescent signal isn't something that predators can see or predators are using, but it's like this secret communication channel that only frogs are able to see and utilize to communicate with each other. I had a lot of luck on my side, where my first two research positions at the University of Michigan in undergrad, one was studying biofluorescence, but for medical applications, and then another was looking at tropical tree frogs. I got connected with the museum and got to work with frogs there and really enjoyed it. And then as I was applying to grad schools, the very first biofluorescent frog was discovered, and my two research worlds perfectly collided. And that was a lot of luck. But then getting into grad school, I knew I wanted to explore that and try to figure out why and how this new trait came about.